This is FE Peer Review. The date is the 5th of October 2021. Acute View Angles at the Horizon. Pause here for a moment for any who are interested in reading, and we will move on. I was thinking about this insistence on the part of some people that there's some sort of Rayleigh criterion angle, small angle issue happening at distant observations, long distance observations, that's causing things near the horizon to disappear. And it sort of flashed on my mind that there may be a reason behind that misconception. There may be a seed of truth that's leading to a misconception. And so I built this little model here in SketchUp. And what we've got is a checkerboard floor. Those are 1 meter squares. And for those of you not comfortable with metric, a meter is a few inches more, about just under 4 inches more than a yard. So these squares are a little larger than a yard, just to give you a sense of scale. So I've created this model, which has got a floor, a checkerboard floor, and then a building, a structure of some sort that's got the same 1 meter checkerboard as a wall surface. And so what we have when we look at this here, for example, is we have a floor surface and a wall surface, and the rectangle and the squares are identical size. They're exactly the same size. However, some squares, these floor squares are horizontal and the wall squares are vertical. Now every 10 meters I've created a little post here. That post, the top of that post, the tip of that post there is at eye level, approximately 1.7 meters, which is about 5 foot 8 inches. So we're going to call that the height of a person standing there, the height of their eyes. And we can move around this model here and see what happens as we look at that distant surface. So we completely lose detail in the floor, not very far away. But the wall remains clearly visible. The squares on the wall remain clearly visible. And this is purely a question of angle. So we're going to take a look at some of these angles now. I've drawn here 2 scenarios. I've got a red and white column here up close. This is 10 meters away, or about 34 feet away from this post. So being closer, we can see that from our viewpoint, top of that post there, the person looking at it sees as an angular measurement of this much to see that bottom 1 meter of the wall, whereas that person only has an angular measurement of that much to see the bottom, to see the 1 meter square on the floor. So there is a very big difference between, they're exactly the same size squares, but because one is oriented vertically and the other is horizontally, it makes a huge difference in how they are seen from this vantage point. I've got a view set up that puts the camera right at that point, which means we don't see this point on the computer screen because it's underneath us. Basically, it's the camera point. So I'm going to go there, and we see that the bottom square is perfectly in view, and the floor is quite tight. The angle for viewing the floor is quite tight. That's an object 10 meters away, seen from a height of 1.7 meters. And then we can look at a more extreme version of that. This wall is 100 meters away, so that's the length of a football field there. American football for my American viewers. And what we've got is, believe it or not, there's actually 2 triangles here. There's the one that's set up to see the wall, but then, and it's hard to see it there. There's one to set up to see the 1 meter square on the floor. See this square right here. And if we want to compare those angles, it's extremely difficult even to compare them because there's such an extreme difference between them. So that angle is, of the large triangle, that acute angle there is under 1 degree. It's about 0.6 of a degree. The smaller of the two angles is so small that I can't even really select it. It's difficult to get a hold of it. All right, I got it. So we're looking at now the triangle. It has a point here, a point here, and a point at the viewer. And that angle is minuscule. In fact, if I ask SketchUp what the angle is, it's going to tell me it's 0 because it's so much smaller than 0.1 degree, and this is set up to 0 out at 1 degree. So you can see the issue there. I think this might be some of the confusion as to why some people think that the angles at the distance near the horizon are making it impossible to see things at the horizon. That is true. There is a Rayleigh criterion issue, or at least we're approaching it just way too small of an angle. Whether it's actually the Rayleigh criterion angle, I can't say. But when we're talking about a floor surface, however, that's not the case when we talk about a wall. So there you go, something to think about. I could have done the math here, and if it would help people for me to do the math, I will be happy to do so. But I thought that these images might be enough to explain the concept. Hope this was helpful. Have a nice day, everybody. Bye-bye.